Now this is functions module INE question number 33, second part. Now fx function is given in this question, and we are supposed to discuss whether fx is an odd function or even function. Now what we do, we assume numerator function as gx function and denominator function as hx function. And gx is an even function. So easy to see. You can see, replace x or minus x, this becomes minus x, and you replace x or minus x in sin x, becomes sin of minus x, and tan x becomes tan of minus x. We take minus out of the sin term, minus out of the tan term, and there's already a minus sign outside, and together it becomes a plus sign outside. And now you can see g of minus x becomes gx. So it means gx is an even function. Now to see where hx, to decide about hx, let's write steps. This part is difficult here, deciding about hx, and because greatest integer function is involved. You make two cases here. First is x equals to n pi, and second is x not equals to n pi. When x equals to n pi, we replace x equals to n pi here, and we cancel pi with pi, and greatest integer of n is n, because n is an integer. So hx is a constant function when x equals to n pi, and you know constant function is an even function. Constant function on graph means horizontal line, and it's an even function because you can see a symmetry about y-axis. That is how even. Value at 1 would come out to be same as value at minus 1. Value at 2 will come out to be same as value at minus 2. So this is how it is an even function. Now if you just check fx, fx is gx by hx. Gx is even, we have already shown that. Hx is even for x equal to n pi, we have just shown that. And the ratio of the two even functions is an even function. Now case 2 is x is not integral multiple of pi. Now to understand this case, we are not going to apply, not going to follow the procedure where we replace x by minus x and see whether minus comes outside or not. If it comes out, it is even function, odd function. If it doesn't, then it is an even function. If function is changed, then it's neither of the two. Now we follow a different approach here. We express this hx function, which is a piecewise defined function, into pieces, into compound form. We show some pieces, though it has infinite pieces. We show some pieces. We make, for example, minus 2 pi to minus pi, right? And you can make intervals about the critical points of this. Critical points are integral multiples of pi. So in this interval, when x is between minus 2 pi and minus pi, right, then x by pi is between minus 2 and minus 1, and then greatest integer of x by pi is, if x by pi lies between minus 2 and minus 1, then greatest integer is minus 2, and if you multiply with 2 and add 1, it becomes minus 3. That is what I have written here, minus 3. Similarly, between minus pi and 0, it becomes minus 1, 0 and 3, and from here you can see it's an odd function. And between 0 and pi, and between minus pi and 0, the difference of sign is there. Same here. Or another approach would be to see this with the help of a graph. If you draw graph of hx function, it is 1 for 0 to pi, pi to 2 pi, it is 3, between minus pi and 0, it is minus 1. I mean, let's not draw at integral multiples of pi because we are taking x not equal to n pi. It is minus 1. Between minus 2 pi and minus pi, it is minus 3. And you can see there is a symmetry about origin. Don't go for the scale. This is 1 and this is minus 1. So if we take reflection in about origin or reflection in both the axes, graph will be symmetrical about origin. That shows it's an odd function. Now fx, let's look at fx. Gx is even, hx is odd, and ratio of even and odd is an odd function. So the final conclusion is hx is even when x equals to n pi. It is odd when x not equals to n pi. I hope it is clear.